Hello friends, once again I welcome to you in our this today's lecture from the unit that is of measures of dispersion. Friends, as you know that we have been learning some most important points from the paper 5th, that is Biostatistics. And from that one, in the last lecture, we have got idea about what is the meaning of measures of dispersion. What is meaning of measures of dispersion? What is the need? What are the objectives of measures of dispersion? Then we have learned many things under this unit, and finally we have got idea about the one of the most important measures of dispersion, that was a range, isn't it? Highest value minus lowest value is the formula for that one. Again, we have learned merits and demerits of that measures of dispersion, that is of a range. Now, in this today's lecture, we have to get idea about the mean deviation. My friends, we have to get idea about mean deviation. Mean of all the deviations in given set of data obtained from average. Mean of all the deviations in a given set of data obtained from a average. In case of the deviations is a greater than the mean. In case, suppose there is a deviation is greater than the mean, the deviation is a positive. If, or in case of the deviation is lesser than or lower than the mean, then the deviation is negative. Keep in mind, deviation is a negative. Mean deviation is also known as average deviation, my friends. Mean deviation is also known as a average deviation. In case the deviation taken from any average, especially from mean, median and mode, while taking their deviations, we have to ignore the negative items and consider only positive items. So these things you have to learn first of all, or understood first of all, in case of the mean deviation. What is mean deviation? Or that is always represented by MD. That is mean deviation. Mean of all the observations in a given set of data obtained from the average. In case of the deviation is greater, if the deviation is greater than the mean, that deviation is a positive one, we have to mention. If the deviation is a less than the mean deviation, then it is to be considered as a negative. Mean deviation, my friends, is also known as we have seen, the average deviations. In this case, the deviation taken from any average, especially that is from mean, median and mode. While taking their deviations, we have to ignore the negative items and consider only positive items. Now, my friends, as usual, we know that we should have idea about what are the merits and what are the demerits of the mean. That we have to learn. So, merits of the mean deviations are, it is easy to calculate and readily understood. We can calculate very easily mean deviation from the given data, and not only we can easily calculate, but also we can easily understand the what type of results of that given observations are there. It is based on all observations. No doubt, once again I will tell you, there should be such a type of a deviation that could have to give justice to each and every observation, each and every item of the population. So this mean deviation definitely gives I have to say that, the justice to the each and every observation. That's why it is based on, so mean deviation is based on the observations. It is less affected by the extreme items from the population. So you'll have to keep in mind, again, another merit of the mean deviation is that it is not affected by, suppose some extreme observations are there in the population or in the data. It is a good measure for the comparison of two distributions. That is most important. It is a good measure for the comparison of two distributions. It is flexible in the sense that it can be calculated from any measures of the central tendency. As already we have seen, it is very easy to calculate the mean deviation, although central tendency has been first of all used there, like the mean, mode, median. From that also, so it is a flexible in sense that it can be calculated from any measures of central tendency. Central tendency. As we have learned the merits of mean deviation, it would be a very easy to, we have to understand about the demerits of the mean deviation. It can be used for further mathematical processing. It cannot be used. It cannot be used for further. Mean deviation about the mean cannot be calculated when the open end classes are given. So not is there. It cannot be used for further mathematical analysis or processing. So it never provides such a type of things. Also, mean deviation about the mean cannot be calculated when there is a open end classes are given. So these are the two demerits of that one. Friends, now we have to get at about standard deviation. ESD, that is most important used measures of dispersion in the research. That is a standard deviation, because you will have to concentrate on this one. You will have to take some examples. You will have to solve the examples using the standard deviation formula, my friends. So here, what is standard deviation? That is the square root of a variance. Square root of a variance is the definition of a standard deviation. Now, what are the merits of that standard deviation? So, very popular scientific measure of dispersion. Already I have told you, because when we are collecting the data of the experiment, definitely we have to calculate the standard deviation of that one, and then we will have to further analyze or conclude about the observed data or observations, isn't it? So standard deviation having a lot of importance in the scientific measures of dispersion. Rigidly defined, its definition is too much clear. Comparison of the two or more distributions which have the same units of measurement is possible with the help of a standard deviation. It is definitely standard deviation based on all observations in the data set. All observations have been considered at the time of calculation of a standard deviation. So that is also one of the most important merit of a standard deviation. It is not much affected by the sampling fluctuation. Suppose there is a fluctuations at the time of sampling, or we have to say that maybe due to person or due to some difficulty, there is a fluctuation in the sampling that will not affect on the final value of a standard deviation. So this is also one of the most important merit of a standard deviation. The units of measurement of a standard deviations are same as that of the data. It is adaptable for the mathematical treatments, in the sense once we have calculated the standard deviation, it is possible. That is not possible in case of mean deviation, as we have seen that is a demerit of a mean deviation, already we have studied. But in case of standard deviation, the figure, the result or the calculated value that can be further analyzed for again getting detailed information, detailed conclusion we can make by analyzing, by further processing the standard deviations. Also, as we know that actually some demerits are there of a standard deviation. It gives a mere weightage to the values that are away from the mean and less than those values that are near to the mean. According to this, one of the most important demerit is that we know that actually, although all observations have been considered at the time of calculation of a standard deviation, it is very difficult, we have to say. Means there is a little bit problem actually. It never gives weightage to the values that are away from the mean and less than to those values that are near to the mean. So mere value weightage is there, and again from the mean and less to those values that are near to the mean. The values which are very close to the mean have no that much importance given at the time of calculation of a standard deviation. So like that one, although we are going to say that there is a consideration of all observations at the calculation of a standard deviation is there, some demerits are there. It cannot be computed for the distribution with open end classes. It cannot be calculated computed for the distribution with open-end classes. It cannot be used for the comparison of the two sets which are expressed in different units. Same units sets should be there so as to compare those things, but that is not possible whenever that units are expressed with different units. So that is also one of the demerit of a standard deviation. Now here, my friends, we will get idea about again standard deviation formula. This standard deviation is always mentioned with the yes letter, isn't it? Now standard deviation, as already we have seen, that is a square root of a variance. It measures a spread of set of observations. It is the absolute measures of dispersion. Formula is given, yes is equal to under root of a summation in bracket x minus x bar bracket square divided by n minus 1 is there. Now the steps to calculate, my friends, steps to calculate the standard deviation. Here you will be able to understand steps to calculate the standard deviation. Here the formula is well known to us, that is yes is equal to under root of summation x minus x bar bracket square divided by n minus 1, that is equal to under root of a summation dx bar bracket square divided by n minus 1, where yes is the sample standard deviation, dx bar is equal to x minus x bar. Their steps: calculate the arithmetic mean of the observation. First calculate the x bar value from the given data, that is we have arithmetic mean we have to calculate. Find the deviations of individual observations from the mean and denote by, that is d square. Then square these deviations and total the atoms, total them as a summation in bracket dx bar bracket square. Now divide the sum of summation dx bar by the square by the total number of observations and then extract the root. This is the value of standard deviation. My friends, example is given here. Calculate the standard standard deviation, I have to say, from the following data. Variables are given, that is x value 10, 13, 17, 22, 27, 30, 31 and 32 are there. Now we have to calculate the dx bar, that is equal to, first of all we have to x bar value, calculate x bar is equal to summation x divided by n. So summation x is equal to 182 divided by 8, because 8 observations have been considered for the summation, so that is 22.75. Now dx bar, that is equal to in bracket x minus x bar value we have calculated, that is 22.75. that value we have to consider to 10 minus 22.75, that is minus 12.75 is there, isn't it? Now here at the time of square we have to x minus x bar, so 12.75 square 162.56, that is plus 975 is 95.6, 5.75 is 33. So these values x bar summation in bracket x minus x bar bracket square is equal to, त्याची टोटल केली तर 515 means 515.48 is there. So formula is with us. According to formula, square root of a 515.48 divided by 7, that is equal to under root of a 73.64. Final value is 8.58 is the standard value that we have calculated by using. So such a type of a, again examples you have to write on your own. Take the help of a books. Many books are available in the library or that are available on online. Examples are also available on online on Google, that you will have to try to solve, and then again you can see either your answer is correct or wrong. That is also mentioned in that one. So this practice, you have to practice makes man perfect, my friends. Now again, standard deviations, merits and demerits are given here to understand very easily. Very simple slide I have prepared here for you. That is, merits are rigidly defined based on all observation less affected by the sampling fluctuations. Demerits difficult to calculate when compared to other measure of dispersion, give more weightage to the extreme values and less to the values which are near to them. Now another measures of dispersion we have to study, that is a coefficient of variation, CV. Standard deviation is an absolute measure of dispersion. Standard deviation of the height of the plant is compared with the weight of the plant. They are difficult. Thus, must be converted into a relative measure of dispersion for the purpose of comparison. Thus, relative measure of dispersion is called as a coefficient of variation. So, my friend, what is difference between standard deviation measures of dispersion and coefficient of variation measures of dispersion is that in case of standard deviation, we know that that is an absolute measure of dispersion. But whenever there is a height of plant, we want to compare with the weight of the plant, then that is not possible with the help of a standard deviation absolute measure of dispersion. For that, we'll have to go to the another measure of dispersion, which is a relative measure of dispersion, that is a coefficient of a variation. It helps to measure the variability of a two or more samples. Smaller the coefficient of variation, greater the consistency. Smaller the coefficient of variation, greater the consistency. Less the coefficient of variation sample is the less homogeneous. So CV is equal to standard deviation divided by x bar into 100. Formula again you have to keep in mind. Coefficient of variation, that is equal to standard deviation divided by x bar into 100. Here example is there. Measure of dispersion and arithmetic mean of average. Therefore, the resulting percentage, the ratio is known as coefficient of variation. From the above data, compute the values of the coefficient of variation. Compare the two series from the data consistency. Series A x bar is equal to 34.60. Standard deviation is 14. Series B x bar is equal to 27. So my friends, example is there, formula already I have told to you. You will have to try to solve that problem. Try to calculate the standard deviations with the coefficient of variations with the help of given formulas to you. Again, my friends, this slide tells us that एखाद्याचा पराभव करणं फार सोपं असतं, मात्र एखाद्याला जिंकून देणं खूपच अवघड असतं. माय फ्रेंड्स, I have already given you idea about what actually this our very honorable, very, I have to say that devoted person to the science and to the country, our honorable former president Dr. APJ Kalam. Why telling all these things? Because my friends, in our life we know that there is a lot of contribution has been given to us, by a lot of contribution in our life is given by our parents. So we'll have to make them to win. आता तुमच्या लक्षात येणार असेल, आई वडिलांना आपल्याला जिंकून द्यायचं आहे, गुरुजनांना आपण जिंकून द्यायचं म्हणजे काय, तुम्ही मोठं पद अचीव केलं पाहिजे. जर एखाद्या IAS अधिकाऱ्याचे आई वडील एखाद्या कार्यक्रमाला गेले तर त्या IAS अधिकाऱ्याच्या आई वडिलांना तिथली लोक फार मोठा मान सन्मान देतात. कशामुळं? मान सन्मान जिंकल्यावर मिळतो. कोण जिंकलं ॲक्च्युली, कुणी जिंकून दिलं त्यांना तो मान सन्मान, कुणी दिला? जे आई वडील छनीनं हातोडीनं दगड फोडत होते जे हात रस्त्यावरती भर उन्हात, त्यांना तशा पद्धतीचा सन्मान का, तर मुलगा त्यांचा IAS झाला. आर यू गेटिंग? सो APJ कलाम जे आहेत त्यांनी आपल्याला जे सांगितलेलं आहे, भारतरत्न डॉक्टर APJ अब्दुल कलाम यांनी आपल्याला काय सांगितलं आहे, आई वडिलांना जिंकून देण्याचं कुणाच्या हातात आहे? दॅट इज इन द वी हॅव टू से दॅट इज अ रिस्पॉन्सिबिलिटी, होल रिस्पॉन्सिबिलिटी ऑफ द स्टुडंट्स, होल रिस्पॉन्सिबिलिटी ऑफ द देअर चिल्ड्रन्स. आणि गुरुजनांना जिंकून द्यायचं कुणाचं आहे? होल रिस्पॉन्सिबिलिटी ऑफ द स्टुडंट्स. आम्ही जिंकणार कधी? तुम्ही मोठे व्हाल, जगात चांगल्या पद्धतीनं नाव कमवून त्यावेळेला. सो विथ दिस माय फ्रेंड्स, आय हॅव टू से थँक यू व्हेरी मच.